strange, it's because they haven't turned on Canvas yet. And here it is. This is Sunday. Class starts on Tuesday, and I haven't put anything up yet. Um, I'm supposed to teach 4 classes this summer, but only one of, well, none of my uh, none of my contracts have been signed, so I'm not exactly sure what's going on. This may be nobody will ever see this. So let's go ahead and get started. What I'm going to do is I'm going to tackle the first 3 chapters. They're pretty short. This is a new textbook. I've never used it before. Um, the reason I'm using it is because it's so inexpensive. It's a good way to say it. So let's go ahead and get started. We're going to tackle the first 3 chapters. The first chapter is just an introduction. The second one is about the historical coverage of research in psychology, and the third one is about ethics. So let's go ahead and get started, I think. Yeah, there we go. Chapter 1, Scientific Psychology. Science has 3 fundamental features. Systematic empiricism. Empiricism means research. If something is empirical, it means that it has to do with research. Empirical questions, questions that support the research. Systematic empiricism, learning based on observation, that has to do with science. Empirical questions, questions about the way the world actually is. And then the last is public knowledge. Science creates public knowledge, and that's supposed to be an O, not a P. I do not type, so sometimes my fingers get off the right keys. Or actually, I only use 2 or 3 fingers when I type. So there you go, public knowledge. But public knowledge is important, and we are seeing this now with the debate about vaccines. Seems like a silly debate at this point, since we have so many kids who have not been vaccinated who are coming down with the measles. Measles is really a dangerous disease. It's a viral disease caused by uh, the rubella and rubeola viruses. It's really dangerous. It's killed millions over the years. Kills about 3,000 people worldwide, and we can stop it just with the vaccines, but there are people that are arguing against it because of conspiracy theories primarily. So, empiricism means learning based on observation. So scientists learn about the natural world systematically by carefully planning, making, recording, and analyzing observations of the known world. Logical reasoning and even creativity play important roles in science too, but scientists are unique in their insistence on checking their ideas about the way the world is against their systematic observations. And this is really, really important. And this is one of the reasons why we use the scientific method when we're talking about psychology. Empirical questions are questions about the way the world actually is, and therefore can be answered by systematically observing it. There are many interesting and important questions that are not empirically testable and that science cannot answer. And one of the things I'm going to ask you to do is to come up with a research proposal. Now, you can come up with a lot of research proposals that you can't measure. Uh, you know, Historical trauma is one of those. Can we measure historical trauma? If we do, um, what are our measurements? How can this be done? Is there a survey that we can do to measure historical trauma? And the answer is probably no. And I'll be talking about my own research. I did my research about 25 years ago. It was dealt with resilience among the indigenous populations. This was on the northern plains. So we'll talk about that as well. So, and I was talking about resilience. Is there a measurement for resilience? And the answer is yeah. There was a survey that I found that we could use that had been used around the world with different populations, and that's how that works. So it has to be something that's testable. You need some instrument to test it. Among them are questions about values, whether good things are good or bad, just or unjust, or beautiful or ugly, and questions about how things ought to be. Of course, these are questions that cannot be answered. Uh, Beauty to one person is probably ugly to another person. You know, if you think he's good looking, do you think that he's ugly? You know, that kind of a thing. Just good and bad is the same way. Is this good? Is this bad? After asking their empirical questions, making their systematic observations, and drawing their conclusions, scientists publish their work. This usually means writing an article for publication in a professional journal in which they put their research question in the context of previous research, describe in detail the methods they use to answer their question, and clearly present their results and conclusions. Publication is an essential feature of science for two reasons. One is that science is a social process, a large scale collaboration among many researchers distributed across both time and space. Our current scientific knowledge of most topics is based on many different studies conducted by many different researchers who have shared their work with each other over the years. The second is that publication allows science to be self correcting. Individual scientists understand that despite their best efforts, their methods can be flawed and their conclusions incorrect. Publication allows others in the scientific community to detect and correct these errors so that over time, scientific knowledge increasingly reflects the way that the world actually is. Now, this is a problem. This is a really serious problem that we're having right now because the internet was invented in 1993. And since 1993, everything is changing at an exponential rate. It's just changing amazingly. There's a lot more connection. There's a lot more communication taking place. Now we have cell phones that are what used to be little computers that are connected to the internet, and this has changed things drastically. It's changed it's changed everything. And this is really kind of amazing if you think about it. So, all the rules that we came up with prior to the internet, are any of those any good anymore? All those social rules that we had before. And one of the things that I want you to notice as we wander through these chapters, just how much of the research that we accept today is prior to 1993. And if it was prior to 1993, is it still true today? There's a lot of things have changed in society. My daughter was complaining about my grandson uh, uh, wanting to be an influencer on the internet today, and of course well, I don't know, he was quite offended that she thinks that he's on the internet too much because he's not on nearly as much as his friends are. They've got 3 days off, and some of them have been on the computer constantly. And of course, I was talking to him after a soccer game. We were eating lunch after a soccer game. So, he spent all morning playing soccer and busting his tail, trying to win the game, and they did. They won the game 5-4. But here she was telling him that he was spending too much time on the internet, spending too much time in gaming. Pseudoscience refers to activities and beliefs that are claimed to be scientific by their proponents and may appear to be scientific at first glance, but they're not really. Consider the theory of biorhythms. The idea is that people's physical and intellectual and emotional abilities run in cycles that begin when they are born and continue until they die. The physical cycle has a period of 23 days. The intellectual cycle is a period of 33 days, and the emotional cycle a period of 28 days. The theory of biorhythms has been around for more than 100 years. The problem with biorhythms, however, is that there is no evidence that they exist and plenty of evidence that they do not. Now, the other thing that you need to notice is this was a theory. This is something purported by Hines in 1998. This is 5 years after the internet was invented. If those of you who were around in 1998 know how slow the internet was or has been in the past, of course, every time we speed it up, we think, oh man, okay, this is amazing. This is so fast. I don't think it could ever be any faster. And then the next thing we know, we've got 3G, and then we got 4G, and then we got 5G. You know, everything is, and the G stands for gigs. And I'm not sure how much a gig is, but we're just accelerating everything exponentially. A set of beliefs or activities can be said to be pseudoscientific if its adherents claim or imply that it is scientific, but it lacks one or more of the three features of science. It might lack systematic empiricism. Either there is no relevant scientific research, or, as in the case of biorhythms, there is relevant scientific research, but it is ignored. And the scientific research is saying this doesn't really exist. It might also lack public knowledge. People who promote the belief or activities might claim to have conducted scientific research but never published that research in a way that allows others to evaluate it. And this is what's going on with the vaccine debate. The vaccine debate is mostly the people who are against it. It's mostly a conspiracy theory, and this science says children need to be vaccinated. And of course, people are not doing it for religious reasons. That's one reason. But there are other people that are adhering to these ideas that have no scientific basis, and they're not vaccinating their children for that reason. And that's because the anti-vaxxers, it is a pseudoscience. Their argument against it. A set of beliefs and activities might also be pseudoscientific because it does not address empirical questions. Karl Popper argued specifically that any scientific claim must be expressed in such a way that there are observations that would, if they were made, count as evidence against the claim. In other words, scientific claims must be falsifiable, and that's one of the reasons why, when you do research, you look for the null hypothesis. In other words, you look at all of the ways that you can look at your research topic, your research question, and you try to find a way that refutes what you think. That's the way science is supposed to work. Now, some of us are so damn smart that it's very difficult for our brilliant ideas to be refuted. At least that's the way we feel. So it's scientists are the same way, and it's difficult to get scientists to actually admit that they might have made a mistake. But that's the way science works. The null hypothesis, you're always looking for something that refutes what you think is true. And once you look at everything. Once you look at everything, now we know that this is true. And hopefully that's what we've done with most of our psychological knowledge. We've tried to prove that it wasn't true, and what we are discovering is that people around the world, the different cultures see things differently, and there is nothing that is 100% true every time as far as psychology is concerned. Gravity does exist around Earth, but it's different on other planets. That's science, I guess. I'm trying to think of something else. Why we're able to breathe oxygen, but breathing pure oxygen is not healthy. Why should we concern ourselves with pseudoscience? There are at least three reasons. One is that learning about pseudoscience helps bring the fundamental features of science and their importance into sharper focus. If we look at why things are conspiracy theories, why they are lies, why it is fake, then we understand science better. That's the way it's supposed to be. But we are dealing with a politics right now that like the conspiracy theories, because the conspiracy theories go against understanding of the real world. And the real world is kind of a dangerous place right now. One one thing that's happening is global warming is taking place, and we know that that's happening. Science is telling us that it's happening, but there are people that want to refute it, because if we admit that it's there, then we have to do something about it, and they don't want to do anything about it because it's too expensive. One way we could combat global warming would be to cut our carbon emissions. But if we cut our carbon emissions, it's going to cut into their profits. Oh man, isn't that terrible? Profits are more important than people. Oh, I guess it's always been that way. A second is that the pseudoscientific beliefs are widely held and are promoted on the internet, on television, and in books and magazines. Learning what makes them pseudoscientific can help us to identify and evaluate such beliefs and practices when we encounter them. And there's a lot of it out there. And oh man. Sometimes, in order for you to have a job, you've got to accept those pseudoscientific beliefs. So, a third reason is that many pseudosciences purport to explain some aspect of human behavior and mental processes for pain control. It is important for students of psychology to distinguish their own field clearly from the pseudopsychology that we deal with. And of course, we're dealing with pain control here. There's a lot that pain is a really difficult thing to deal with, um, and we have to accept that. We have to accept that sometimes things hurt, and there's nothing you can do about it. But people will spend millions and millions of dollars trying to fight the pain that they feel. Basic research in psychology is conducted primarily for the sake of achieving a more detailed and accurate understanding of human behavior without necessarily trying to address any particular practical problem. Applied research is conducted primarily to address some practical problem. Although the distinction between basic and applied research is convenient, it is not always clear cut. So basic research is just research. Sometimes it helps, sometimes it doesn't, sometimes it applies to humans, sometimes it doesn't. And sometimes it's just pure research that doesn't really mean anything to you and I. However, applied research does. Scientific research in psychology is generally conducted by people with doctoral degrees, usually the Doctor of Philosophy, PhD. I have a PhD. Dr. Russ has a PhD. These are the people that are teaching in psychology. Dr. Barber has a PsyD, a Doctorate of Psychology, which is not the same thing as a PhD. But his is a 4-year degree. Dr. Russ and I have PhDs. The other degree is an EDD, which is a Doctor of Education, and it's usually a 3-year degree instead of a 4-year degree. So that's the PhD. A master's degree in psychology and related fields, often supported by research assistants with bachelor's degrees or other relevant training. So most of the people doing research at least have a master's degree. A master's degree in psychology takes about 2 years. PhD is anywhere from 4 to 10 years, depending on the program. It took me 11 years to finish my PhD. You can ask Dr. Russ. I think hers took 4 years. Really all depends on your dissertation, how long it takes you to finish your dissertation. The majority are college and university faculty members who often collaborate with their graduate and undergraduate students to help with their research. Free labor. Although some researchers are trained and licensed as clinicians, as counseling psychologists, especially those who conduct research in clinical psychology. The majority are not clinical psychologists. And Dr. Russ is not, I am not, and Dr. Barber is not a clinical psychologist. Though Dr. Barber and I have studied clinical psychology or counseling psychology. They have expertise in one or more of the many other subfields of psychology: behavioral neuroscience, cognitive psychology, developmental psychology, personality psychology, social psychology, and so on. There's like 40 different areas. Dr. Barber's specialty is forensic psychology. My psychology, I do not have a specific area of study. Mine is in general psychology, which means I've studied all of these things. Dr. Russ, her specialty, her PhD is in educational psychology. Scientific research methods are not static. That means they don't just sit still. Researchers in all fields are continually developing new and better measures, procedures, and statistical techniques. In the past decade, there have been some especially broad and sweeping changes in the way that psychologists conduct their research to make it more transparent, more efficient, and more reliable. And these new practices are referred collectively as open science. Open science is difficult because open science means that instead of hiding in the corner and doing your research and then coming out and publishing your paper, open science wants you to allow other people to look at your research and to discuss your research with you, to help you. So that there are others that are working on the same thing at the same time, so that we can show that this is true. If it happens, in Saley, Arizona, does that mean it's going to work in Oklahoma City, Oklahoma? Does that mean it's going to be the same way in Denver, Colorado, or in Los Angeles, California? That's what open science is. Open science says we have a theory. We'd like to test this theory. This is what I get. This is the results that I was able to get in Saley, Arizona. Is it the same anywhere else? Now, what's the difference between Saley, Arizona, and Oklahoma City, Oklahoma? The difference is the number of indigenous people that we're dealing with. If we're in Saley, that's on the Navajo Nation. The number of people who are not indigenous in Saley, Arizona, is very low, if there's any at all. Probably faculty members, and that's about it. But in Oklahoma City, the number of indigenous people is relatively low. It's probably around 10 or 12%. And if we go out to Los Angeles, it's even lower than that. There are many factors that prompted these changes, but one of the most important has come to be called the replication crisis. In science, to replicate a study means to conduct it again to confirm the original results. So this is what I'm talking about. If we did the research in Saley, Arizona, and we replicated it in Oklahoma City, would we get exactly the same results? If we replicated it in Denver, Colorado, would we get the same results? That's what we need to talk about as far as science is concerned. It has to be, we have to be able to replicate it. And right now, what people are doing research in private, and they're not their studies aren't being replicated, but they're publishing. They're publishing and saying, "Hey, look what I found." But researchers were finding that when they replicated certain high-profile studies, they did not confirm the original results. Many of the original results that could not be reproduced had occurred by chance. They were statistical flukes. The problem was that researchers were also engaging in practices that made statistical flukes especially likely to occur, especially easy to publish when they did occur, and especially difficult to correct after they were published. And that was one of the problems with the autism theory of vaccinations. The first individual that did it that said that vaccinations caused autism. His study was flawed. There were too few people in the study, and he kind of cheated a little bit with his statistics. At this point, the individual that did that, I'm trying to think what his name was. I think it's Hopewell. Well, maybe I'm wrong. I just read this when I was putting this chapter together. He has been kicked out of all of the scientific organizations because of what he did. Um, Others have done the same research and they haven't gotten the same results that he got. And it looks like he cheated so much that we can't really trust what the results that he got. But there are people that are repeating his results, or they're repeating what he said because he published. And he became very famous when he published, but then everyone else is going, wait a minute, this isn't true. You're going to kill children. And we can't allow that to happen. The problem is that RFK Jr. believes it. He's not a scientist, he's a lawyer. We won't get into that. Open science practices do not eliminate statistical flukes, but they do make them less likely to occur, more difficult to publish, and easier to correct. These open science practices have become an extremely important part of contemporary science research in psychology, and the reason that the open science is important right now is because the internet has created a platform for people to refute good science, to create conspiracy theories. And sometimes they come up with flawed research. Sometimes it's not based on research, but speculation. And that's a problem. The most important open science practice in psychology, publishing more replication studies to confirm previous results, pre-registering new studies by posting descriptions of the hypotheses, methods, and statistical analyses online before the study is conducted, providing more complete descriptions of how the research was conducted, including how the sample size was determined, whether any data were excluded from the analyses, and whether alternative statistical analysis were conducted. And this is really a serious problem because people like to people want you to think that they're smart, and this is how you get jobs and keep your job, is by doing research. In some institutions, if you work at that institution, it's publish or perish. In other words, you either do research and publish or you lose your job. And of course, because of that, there are individuals out there that are rushing to get published. How do they get published? They come up with this new brilliant idea. Once they publish, of course, now they become famous and people talk about them. I get notices every day that people are using my research, that I have been quoted in somebody's research. Well, I'll talk about my research eventually, because my research had to do with the resilience of indigenous people. Okay, so this is really important to the faculty member because that's how he keeps his job. What if he comes up with a bad idea, or he's just a teaching psychologist, he's not a research psychologist? How in the world does he keep his job? Well, he has to do research, he has to publish or perish. So he starts to do, or she, whichever the case may be, they do their research. It doesn't work out. Nobody's going to publish this because it was bad research. So they throw out all the bad stuff and they just keep stuff that makes it look like his hypothesis was true. You don't publish, or they don't. You should be publishing all the research that you do to show that it either worked or it didn't work. But unfortunately, it is difficult to get negative research published. Oh, look, I had this idea and it was completely erroneous. I was completely wrong. Nobody wants to publish that piece of research. Using larger samples, which are less likely to produce fluke results, and this is another problem. You use a small sample. You use your general psychology class, and there's only 15 people in your general psychology class, so you get 15 you have 15 subjects, and you make this broad generalization about these 15 people. Well, maybe all 15 of these people have red hair, maybe all 15 of these people are left-handed, um, or they're all right-handed, and it didn't take into account somebody that was left-handed. There's just a ton of different reasons, but you have to look at the sample to see if the sample size was large enough for this to be a reasonable piece of research. Making study materials and data publicly available online after the study has been completed, and of course, almost all of your scientific journals are online now. Requiring researchers to include an open science statement in their articles that explicitly acknowledges that open science practices were followed. In other words, you talked to other individuals, you talked about your research, and whether this should be the way things work. Some people wonder whether the scientific approach to psychology is necessary. Can we not reach some conclusions based on common sense or intuition? We all have intuitive beliefs about people's behavior, thoughts, and feelings, and these beliefs are collectively referred to as folk psychology. Although much of our folk psychology is probably reasonably accurate, it is clear that much of it is not. People use only 10% of their brain power. We are only using between 1 and 16% of our brains each moment, but 100% over a busy day or even a conversation. So that is false, that we only use 10% of our brain power. We use 100% of our brains almost every day. Most people experience a midlife crisis in their 40s or 50s. Most people don't experience a midlife crisis, though some people may have a midlife crisis. Not everybody does. I didn't. Students learn, and I'm 75 years old, so I guess if I'm in midlife right now, that means I'm going to live to be 150. I doubt if I'm going to make it quite that far. Students learn best when teaching styles are matched to their learning styles. The reality is that students will adapt their learning style to whatever the teaching style is. In other words, if you go from math class to literature class to a psychology class, whether you're an oral learner or a visual learner, it really doesn't matter. However they present the material, you will be able to adjust your learning style to whatever their teaching style is. Low self-esteem is a major cause of psychological problems. Self-esteem is just one factor in mental health. Psychiatric admissions and crimes increase during full moons. It is statistically exactly the same from day to day to day. It really doesn't matter what the moon phase is. The only difference is that people are only observing during a full moon because they're looking for people to do crazy things. I've worked in the emergency room. I worked in the emergency room for 30 years, and I can tell you that the only time we talked about crazy things that were happening was on a full moon. But I'll tell you what, crazy things were happening every day. Every day. How can so many of our intuitive beliefs about human behavior be so wrong? This is a psychological question, and psychologists have conducted scientific research on it and identified many contributing factors. One is that forming detailed and accurate beliefs requires powers of observation, memory, and analysis to an extent that we do not naturally possess. We tend to rely on mental shortcuts in forming and maintaining our beliefs. If a belief is widely shared, especially if it is endorsed by experts, and it makes intuitive sense, we tend to assume it is true. This is compounded by the fact that we then tend to focus on cases that confirm our intuitive beliefs and not on cases that disconfirm them. And this is known as confirmation bias. So when we look at if we're looking for cases of autism caused by vaccinations, if we see one, we go, see, there you go. It just proves it. That one case proves that autism is caused by vaccinations. But the reality is, if we look at the statistics, the number of people who have been vaccinated who have autism and the number of people who have not been vaccinated who have autism is exactly the same. So one has nothing to do with the other. But when we see another case of a child who didn't seem to be autistic, or at least the parents were in denial before they were vaccinated, all of a sudden they're going, "Oh my, they've got autism." Well, I had autism before. You just were in denial before. I don't know. This is kind of a controversial topic, and it's not controversial as far as I'm concerned because I worked in medicine for 30 years, so vaccinations. I saw it before the vaccinations, where you're much better off being vaccinated. I can assure you, if you think, oh my goodness gracious, we shouldn't be vaccinating for chickenpox. Both my kids had chickenpox. Oh, that was miserable. And now, of course, nobody has chickenpox unless you haven't been vaccinated for it. And I can tell you, after having worked in medicine and having taken care of my children when they had smallpox, had chickenpox, I can tell you you're a lot better off not having to deal with it. I had measles when I was a child. There was no vaccination at the time. And I can tell you that's the only time I've had a fever so high that I had hallucinations. And I still have scars on my hands because my fever was so high. We're also we also hold incorrect beliefs in part because it would be nice if they were true. I don't know. Conspiracy theories are fun. It gives you something to argue about. Scientists, especially psychologists, understand that they are just as susceptible as anyone else to intuitive but incorrect beliefs. This is why they cultivate an attitude of skepticism. Being skeptical does not mean being cynical or distrustful. Instead, it means pausing to consider alternatives and to search for evidence, especially systematically collected empirical evidence when there is enough at stake to justify doing so. You need to be skeptical. Just because Bradway said it doesn't make it true. You need to think about this on your own, and you need to look at the empirical evidence behind it. Because there is often not enough evidence to fully evaluate a belief or claim, scientists also cultivate tolerance for uncertainty. They accept that there are many things that they simply do not know. Although uncertainty can be problematic from a practical perspective, it is exciting from a scientific perspective. If we do not know the answer to an interesting and empirically testable question, science may be able to provide the answer. Psychology is the scientific study of behavior and mental processes. It is also the application of scientific research to benefit society and improve people's lives. The most common and widely known application is the clinical practice of psychology, the diagnosis and treatment of psychological disorders and related problems. However, there are areas of psychology that do not believe in the clinical practice of psychology. They believe they don't believe in the DSM-5. They are skeptical about the DSM-5. They want it all proven scientifically, and they don't think it's been proven scientifically enough. That's one whole area of psychology, is the skepticism about their field. The term clinical practice broadly refers to the activities of clinical and counseling psychologists, school psychologists, marriage and family therapists, licensed clinical social workers, and others who work with people individually or in small groups to identify and address their psychological difficulties. There are people, about 70% of psychologists are clinical psychologists. They work with people in a clinical manner so that they can help them get over whatever problem they seem to have. All clinical psychologists believe in mental illness. Psychological disorders are part of the natural world. Their nature, causes, and consequences are empirically testable and therefore subject to scientific study. As with other questions about human behavior, we cannot rely on our intuition or common sense for detailed and accurate answers. Questions about whether a particular psychotherapy works are empirically testable questions that can be answered by scientific research. If a new psychotherapy is an effective treatment, then systematic observation should reveal improvement from this psychotherapy. An empirically supported treatment is one that has been studied scientifically and shown to result in greater improvement than no treatment, a placebo, or some alternative treatment. Now, okay, so this gets a little strange, and the reason it gets strange is because you and I are not the same. Now, if we had exactly the same problem, say that we had anger issues, and they treated me with a certain treatment and it worked, and they treated you with that very same treatment and it didn't work, is it because the treatment doesn't work? And the answer is no, we're different. We're two different people, so we're going to have different results. And this is the problem with dealing with humanity. You're dealing with different cultures, you're dealing with different ideas, you're dealing with different religions, you're dealing with just a myriad of differences. I'm 75 years old. I have 5 degrees. I'm assuming none of you out there have 5 degrees, and I'm also assuming that none of you out there are 75 years old. So the difference is I've seen lots of different things, but that you haven't seen. So if I respond to the treatment, that doesn't mean that if I do respond to the treatment and you don't, that doesn't mean that the treatment doesn't work. Maybe it just works on 75-year-old people with 5 degrees. That's the problem with psychology, because we're dealing with a lot of different people and we don't all have the same ideas. So the same things are not going to work on you that work on me, and vice versa. If it works on you, that doesn't mean it's going to work on me. Empirically supported treatments for psychological disorders, acceptance and commitment therapy for chronic pain, behavioral activation for depression, cognitive behavioral therapy for adult ADHD, dialectical behavior therapy for borderline personality disorder, exposure therapy for specific phobias, family-focused therapy for bipolar disorder, and stimulus control therapy for insomnia. These are empirically supported treatments that have worked with select individuals, with a majority of the individuals. Some people don't respond to medication. I'm not sensitive to opiates and opioids. They don't work on me. They don't. It's hard to knock me out. Which is a problem because I've had to have surgery from time to time. And, they have to give me enough fentanyl to kill an elephant. Here we go. Chapter 2, basic research. Okay, so we're done with chapter 1. We've talked about chapter 1. And now we're on chapter 2, research basics. There we go. Maybe. There we go. Oh, look where I am. Maybe. I am retiring this year. I am not coming back in the fall. I've been asked to adjunct, but I'm not exactly sure if the administration wants me to, and that may be the problem that may be the reason that your Canvas hasn't worked or isn't up on the first day, but we'll see what happens. There are potential research questions everywhere, but not all can be converted into empirical research questions. Research questions in psychology are about variables, quantity or quality that varies across individuals like height, gender, and age. Variables. Okay, so let's get into my research. I told you that my research was about resilience among indigenous people. And what I wanted to prove was that indigenous people, that was my theory, was that indigenous people are resilient. So I found a measurement to measure resilience. It was a survey that measured resilience. It had been used on various populations around the world, on Germans, on people in Cincinnati, on people in Africa. It had been used, and it had been used successfully by all of these individuals. So I had resilience levels from all of these individuals. And I wanted to prove that American Indians were resilient as well. But just proving that people are resilient doesn't mean a whole lot. What does their resilience come from? So I measured education, I measured gender, are women more resilient than men? I measured age, I measured level of trauma, and I measured culture, strength of culture. Those are my five variables. Those are my independent variables. My dependent variable was resilience. So I was looking at which of these affects your resilience level. A quantitative variable is an aspect that is characterized by assigning a number to each individual, such as height or age. And of course, age and education, your number of years of education, those were both quantifiable variables. A categorical variable is a quality that varies across individuals like gender, nationality, or occupation. I didn't look at nationality, of course, because I was dealing with indigenous people. I didn't look at what occupation they had. What I looked at were my categorical variables had to do with gender. Oh, trauma was quantitative as well, and I had a measurement for culture. So I gave them a survey for culture. They answered questions about trauma. So I kind of had a survey for trauma as well. So I was getting quantitative results for both culture and for trauma and for education and age. So my categorical variable, the only categorical variable I had was gender. Psychological research normally involves numerous tests, usually on a group or of people. If I wanted to research people on the Navajo Nation, my population would be all the inhabitants on the Navajo Nation. That's what, 138,448 people. However, testing all 138,448 people on the Navajo Nation would be impossible. So I would need a smaller representative group referred to as a sample to represent the population, like the students in research method class at Dene College. Now, right now, there's only 10 of you. The last time I looked, there were only 10 people in research methods class. And I think you would agree with me that 10 people cannot represent 138,448 people. And it's just not random. There's not enough people. I need more people to represent the Navajo Nation. So I'm going to use my abnormal psychology class if I get to teach it. There are 33 people in there. So that's what, 43? Yeah, that's 43 people. Is that enough to represent 138,448 people? And the answer is probably no. Probably no. Research sampling methods are broadly categorized into probability sampling and non-probability sampling. Probability sampling ensures every member of the population has a known chance of selection, while non-probability sampling doesn't, often used for exploratory research. Probability sampling examples are simple random sampling. Each member has an equal chance of selection, so I put all 138,488 names in a big hat, and I pick them out. I pick out a certain number. Let's go with 200 names. A stratified sample divides the population into subgroups or strata and samples proportionally from each. But of course, if I pick all 200 of those names out and they're all like 12 years old, well, that's not a very good sampling. So maybe I need to separate people into age groups. Okay, so So now I've got age groups. I've got well, I'm not going to do it on children. I'm just going to do it on adults. So I've got 18 to 30-year olds. I've got 30 to 35-year old, 30 to 45-year olds. I have 45 to 60 years old and older than 60 years old. How's that? Okay, so I picked my 200 people out. Oh man, look at that. 75% of them are male. Oh, that's not going to be a very stratified sample either, is it? So now what I need to do is I need to put them in groups, but I need an equal number of males and females. So that's what a stratified sample is. I'm using categories, and I need to get people from each category. Systematic sampling selects every nth member from a numbered list, and of course, it could turn out that every nth member, all 200 of my people turn out to be female, or every nth member turns out to be, a 3-year-old. Oh, man. Cluster sampling divides the population into clusters and randomly selects clusters from sampling. And of course, that's what I am proposing to do. Non-probability sampling, purposive sampling, researcher selects participants based on specific criteria, often used in qualitative research. Say that I was looking at people who had worked in uranium mines to see what kind of problems they have. That would be purposive sampling. Convenience sampling, researcher selects participants based on ease of access, and that's convenience sampling would be if I just used my students from research methods and from abnormal psychology. That would be a convenience sampling. Most sampling is convenience sampling. Snowball sampling, researcher asks participants to recruit other participants. So let's say that I was looking at I wanted to do research with individuals who have a sexual orientation of same-sex relationships. Well, there's only one person in my class who is has a same-sex relationship, sexual relationship. So I asked that select individual if they will find friends who would be in my research, and that would be snowball sampling. I said, sure, yeah, I've got an organization, and here, we'll just test everybody in this organization. Quota sampling, researcher selects participants match certain characteristics or quotas. Critical case sampling, researcher focuses on specific cases that can shed light on the research question. With my own sampling was census sampling. I couldn't get permission to do my research on the reservation, so I did research off the reservation, and I chose everyone that I knew had indigenous ancestry, and I usually told that by the name. If the name was common on the reservation, then I tested those individuals. I sent surveys out to everybody, and so I was only dealing with 2 counties, and I chose all these names, and there were about 175. I had 175 names of people off the reservation, and so I actually got 100 of them back, which is pretty good. Actually, it's more than 100, like 108 or something like that. Out of 175 is pretty good. Before a researcher can begin collecting samples, they have to define what exactly the sample is. This is done through an operational definition, a definition of a variable or a construct in terms of precisely how it will be measured. And this is the hardest part. So before I started my research, I had to define what resilience was. And my definition of resilience was a score on this specific resilience scale. Culture. I had a culture survey that I gave the individuals. And so that was my definition of culture, was how high you score on this culture scale. Trauma was the same way. I had a trauma scale, and trauma was defined as a high score on this trauma scale. There you go. And those are the three surveys that I gave my clients, my subjects. And those were my definitions. Research questions in psychology are more likely about statistical relationships between variables. And what I was looking at resilience and age. And I created a scatter plot to see if it was positive or not. There is a statistical relationship between two variables when the average score on one differs systematically across the levels of the other. And of course, that's what I was looking at. How is your resilience score for people that are older, for people that are younger, for people that are middle-aged? Do they have a resilience score that goes up exponentially as they age? So older people are more resilient than younger people. And actually, that's not what happened at all. I'm just giving you an example. I mean, that would be one way to do it. But my scatter plot was all over the map. And for that reason, we're going to talk about what that means. But age had nothing to do with resilience, as interesting as that is. There are two basic types of statistical relationships. Differences between groups. The differences between groups is usually described by giving the mean scores and standard deviations in the form of a bar graph. Correlations between quantitative variables. And this is kind of interesting. This has to do with, flavor preferences for gender. So they're trying to figure out if men and women had the same, they were talking about ice cream. So they wanted to know whether men liked one flavor more than women did. And as it turns out, yep, men like vanilla and women like chocolate ice cream. And strawberry was right in between. And interestingly, I just had a strawberry milkshake. So I'm right here. I was just as sorry, I could have been either a male or a female. But if I had ordered vanilla ice cream, males like vanilla ice cream more than chocolate ice cream. And women like chocolate ice cream more than vanilla ice cream. There you go. It's interesting, and it's just a flavor preference. So it was really kind of an interesting study. A second form of statistical relationship is a correlation between two quantitative variables where the average score on one variable differs systematically across the levels of the other. Correlations between quantitative variables are often presented using scatter plots. And this is what I was talking about. So when it came to age and resilience, this is what I got. No relationship whatsoever. A positive relationship is one where an increase in one variable leads to an increase in its correlated variable, and the scatter plot angles up to the right. This is a positive relationship. And I didn't get that with gender. I didn't get that with age either, as curious as that is. Yeah, I didn't get this with age, and I also didn't get it with gender. And I also didn't get it with trauma. What else? Oh, education. And I didn't get it with education. All of them look like this. The only one that I got a positive relationship with was culture. The stronger your culture, the stronger your resilience was. It's curious. Now I've given you all the secrets to my research. A negative relationship shows a decrease in one variable as the other increases in scatter plot angles down from left to right. This is a negative relationship. So if you do a scatter plot and you got this, it means as the resilience goes up, something goes down. That potentially could have been trauma. Now, curiously, in all the populations that had looked at trauma and resilience had gone, the more trauma they had had, the less resilient they were. They had a negative relationship between the trauma and and resilience. But with mine, it was this. Now, this is really kind of curious because all the other populations have a negative relationship between trauma and resilience, But American Indians, and this was the third study that had shown that, one of them was done on the Hopi Reservation, um, and the other one was done on the Navajo Reservation. And of course, mine was done up on the Northern Plains with the Northern Plains tribes. And this is what we got, which is really curious. So the trauma doesn't affect your resilience level if you are an American Indian. If you are not, if you're African American, if you're Caucasian, if you're Hispanic, then it does affect. The level of trauma does affect your resilience. The strength of a correlation between quantitative variables is typically measured using a statistic called the Pearson's R. And this is Pearson's R. It runs from a -1 to a +1. And if it's in the middle, this is what it looks like. And that's what all mine were except for culture. And culture was positive. This is what my culture and resilience look like. A measure of the strength of the correlation between two quantitative variables, we're talking about Pearson's R. Pearson's R ranges from, we already talked about that. A value of 0 means that there is no relationship between the two variables. When Pearson's R is 0, the points on a scatter plot forms a shapeless cloud like that. As its value moves toward -1 or +1, the points come closer and closer to falling on a single straight line, just like this, or just like that. So you would call this a positive relationship, call this a negative relationship. And this is a very negative relationship. This is a very positive relationship. Pearson's R is a good measure only for linear relationships in which the points are best approximated by a straight line. It is not a good measure for nonlinear relationships in which the points are better approximated by a curved line. Nonlinear relationships are fairly common in psychology, but measuring their strength is difficult. And of course, yeah, this is because of culture, because people are different, because of different ages, because they were raised in urban area as compared to a rural area. People have different ideas. So most of psychology doesn't have a lot of positive or negative relationships. They're usually like this or this or this. There is just no relationship between one thing and the other. Researchers are often interested in a statistical relationship between two variables because they think that one of the variables causes the other. That is, the statistical relationship reflects a causal relationship. In these situations, the variable that is thought to be the cause is called the independent variable. A variable that is thought to be the cause of another variable is called the dependent variable. The dependent variable in this case is the growth of a plant. The independent variable is how much you water it. In an experiment, the independent variable is manipulated by the researcher, and the variable that is thought to be the effect is called the dependent variable. A variable that is thought to be the effect of another variable is called the independent variable. And that's why I was looking at age, gender, trauma, level of culture, and what was the other one? Education. Those are my independent variables. These are the ones that were supposed to affect my dependent variable, which in my case was resilience. I hope that all that makes sense. I wasn't manipulating the independent variables. I was allowing the independent variables, I was testing the independent variables to see what their quantitative structure was. And once I got those figures, then I compared the figures to my dependent variable, and I found that there was, in 4 of the cases, there was no effect. Only one of the cases, only one of the independent variables affected my dependent variable, and that was the level of culture that you maintained. But not all statistical relationships reflect causal relationships. This is what psychologists mean when they say correlation does not imply causation. There are 2 reasons that correlation does not imply causation. The first is called the directionality problem, the problem of knowing whether 2 variables, x and y, are statistically related because X causes Y or because Y causes X. Two variables, X and Y, can be statistically related because X causes Y or because Y causes X. But the reality may be uh, when it's hot, the amount of ice cream that you consume goes up and people are more likely to get sunburn. So does ice cream cause sunburn? Or does sunburn cause people to eat more ice cream? And the answer is no. Ice cream and sunburn have nothing to do with each other. It just so happens that both of them go up when it's hot outside. The second reason that correlation does not imply causation is called the third variable problem. The problem of knowing whether two variables, X and Y, are statistically related because one causes the other or because some third variable, Z, causes both X and Y. Two variables, X and Y, can be statistically related not because X causes Y or because Y causes X, but because some third variable causes both X and Y. Now, the probability, as I did my research looking at these five variables, now there may be something else that causes resilience that I didn't measure, something else, and it was mentioned to me by a colleague that maybe I should have measured spirituality. But I didn't want to measure spirituality, not because I thought that spirituality might have caused resilience. I didn't want to do that because spirituality on that reservation had lots of different definitions. The Native American church was really strong. Traditionalism was very strong. There's an evangelical movement on the reservation that was very strong. Most of the individuals on the reservation were Catholic. Now, so when we're talking about spirituality, which one was I going to focus on? And the answer was I couldn't focus on any of them because they were all so different. So I didn't measure it at all. But the reality may be that spirituality causes resilience, and I didn't measure it at all. Now, this joke is really kind of important. According to the Stanford, I'm going to read the joke. But according to the Stanford marshmallow experiments, kids can look at a marshmallow for a long time without eating it, tend to be healthier, smarter, and richer. And this was an actual study that was done at Stanford University, where they brought children in of different ages, and if they had the wherewithal to not, they were told if they could either eat the marshmallow now or they could wait and get two marshmallows if they waited until the experimenter came back in 15 minutes. So the children that ate the marshmallow right away, they tended not to be as healthy, not as smart, and not as rich. The children that had the ability to wait and get two marshmallows were smarter, healthier, and richer. That's what they discovered. So that was the result of the study. The solution is clear, she says. We must use CRISPR. CRISPR changes people's genetic structure to alter every child's gene expression so they dislike the taste of marshmallows. This should result in all children being superior within a single generation. I don't know if we should conduct novel gene therapies on babies at the same time. I see you're in the pocket of Big Marshmallow. In other words, this was her solution to making people smarter, healthier, and richer was by changing their genes so that they didn't like the taste of marshmallows. And of course, one thing doesn't have anything at all to do with the other. I don't like marshmallows, and I have 5 degrees. I don't know if that has anything to do with anything. Probably not. An experiment is a type of empirical study in which an independent variable is manipulated and a dependent variable is measured while extraneous variables are controlled. That's an experiment. Experiments eliminate the directionality in the third variable problems and allow researchers to draw conclusions about causal relationships. Now, science is looking for causation, but when we're talking about humans, it's a little bit more. There are just too many variables. to manipulate. Good research must begin with a good research question. Yet, coming up with a good research questions is something that novice researchers often find surprisingly difficult. Research questions often begin as more general research ideas, usually focusing on some behavior or psychological characteristic. Three of the most common sources of inspiration are informal observations, practical problems, and previous research. Informal observations include direct observations of our own and others' behavior, as well as secondhand observations from non scientific sources such as newspapers and books. Some of the most famous research in psychology has been inspired by informal observations. Practical problems can also inspire research ideas, leading directly to applied research in such domains as law, health, education, and sports. Probably the most common inspiration for new research ideas is previous research. Science is a kind of large scale collaboration in which many different researchers read and evaluate each other's work and conduct new studies to build on it. Experienced researchers are familiar with previous research in their area of expertise and probably have a long list of ideas. This suggests that novice researchers can find inspiration by consulting with a more experienced researcher. For example, students can consult with their faculty member. And these are places where you can find research ideas. Once you have a research idea, you can use it to generate one or more empirically testable research questions, that is, questions expressed in terms of a single variable or relationship between variables. One way to do this is to look closely at the discussion section in a recent research article on the topic. This is the last major section of the article in which the researchers summarize their results, interpret them in the context of past research, and suggest directions for future research. These suggestions often take the form of specific research questions, which you could try to answer with additional research. You may want to generate your own research questions. First, if you have a particular behavior or psychological characteristic in mind, you can simply conceptualize it as a variable and ask how frequent or intense it is. If the question has never been studied scientifically, which is something you would learn when you review the research literature, then it might be interesting and worth pursuing. Now, you might say, oh, there's just too many people that are alcoholics. How can we study that? What should we do? That's one way of looking at it. You might say, it seems like people who don't work are more likely to be alcoholic. This is how we come up with different ideas. And what happened with me, the reason I came up with resilience as a research topic is because I was looking at the problems on the reservation. And there were a lot of problems on the reservation. Where I was, there was a crystal meth problem. There was a drinking problem, unemployment problem. What else did we? There was a problem with. There was a problem with agoraphobia on the reservation. It's weird. People would just like lock themselves in their houses and not come out for a year or whatever. Somebody would be bringing them food. They'd be too scared to come out. It was really kind of weird. But I thought, geez, everybody talks about all these negative things about American Indians. Why don't I research something positive? These are, I by this time I'd made friends with a lot of people on the reservation. I was working at powwows, and I saw all this positive stuff, and I thought, why in the world should I come up with another negative study about American Indians? Why not find something positive? And that's where I came up with the idea of resilience. The rest of it gets kind of tricky. They didn't want me to do positive research. They wanted me to do negative research so they could get more funding to, fight alcoholism and fight crystal meth and fight agoraphobia. It was just kind of weird. They didn't want me to say anything positive. They just wanted me to help them get more funding. If scientific research has already answered the question of how frequent or intense the behavior or characteristic is, then you could consider turning it into a question about a statistical relationship between that behavior or characteristic and some other variable. One way to do this is to ask yourself the following series of more general questions or write down all the answers you can think of. What are some possible causes of the behavior or characteristic? What are some possible effects of the behavior or characteristic? What types of people might exhibit more or less of the behavior or characteristic? What types of situations might elicit more or less of the behavior or characteristic? If through this process you generate a question that has never been studied scientifically, which again is something that you would learn when you review the research literature, then it might be interesting and worth pursuing. But what if you find that it has been studied scientifically? Although novice researchers often want to give up and move on to a new question at this point, this is not necessarily a good strategy. The fact that the question has been studied scientifically and the research published suggests that it is of interest to the scientific community. The question can almost certainly be refined so that its answer will still contribute something new to the research literature. A research question is interesting to the extent that its answer is in doubt. The fact that a question has not been answered by scientific research does not necessarily make it interesting. There has to be some reasonable chance that the answer to the question will be something that we did not already know. One approach is to try to think of reasons to expect different answers to the question, especially ones that seem to conflict with common sense. If you can think of reasons to expect at least two different answers, then the question might be interesting. If you can think of reasons to expect only one answer, then probably it's not. A second important factor to consider when deciding if a research question is interesting is whether answering it will fill a gap in the research literature. This means in part that the question has not already been answered by scientific research. It also means that the question is in some sense a natural one for people who are familiar with the research literature. A final factor to consider when deciding whether a research question is interesting is whether its answer has important practical implications. I don't know why I put that picture out there. A second important criterion for evaluating research questions is the feasibility, the extent to which a research question can be answered with available resources. There are many factors that affect feasibility, including time, money, equipment, and materials, technical knowledge and skill, and access to research participants. Researchers need to take these factors into account so that they do not waste time and effort pursuing research that they cannot complete successfully. And this is a huge problem. This is one of the reasons why I'm not asking you to do research. I'm just asking you to come up with a research proposal. The probability that it's going to cost you too much money to get it done is really, really high because you're dealing with the Navajo Nation potentially. If we did research in Chinle, or if we did research in Saline, uh, would that represent the entire Navajo Nation? We got people in Thoreau, we got people in Kayenta, we got people in Mexican Hat, we got people over by the Grand Canyon, we got them down in Dilcon. Are they the same? People in Ganado, are they the same as people out in Pinon? And the answer is probably no. The closer we get to the Utah border, the more likely that individuals have a different spirituality. The farther east you go, the probability is that their culture is a little bit different than the people that are over by the Grand Canyon. Dialects are different. Feasibility is difficult. It's one of the things that you have to ask yourself about. Looking through a sample of professional journals in psychology will reveal many studies that are complicated and difficult to carry out. At the same time, looking through a sample of professional journals will also reveal studies that are relatively simple and easy to carry out, perhaps involving a convenient sample of college students and a paper and pencil task. And that's what I was doing with mine. I didn't use just my students. As a matter of fact, I couldn't use most of my students because they lived on the reservation, and I could not get permission to do my study on the reservation. So I had to do it off the reservation with indigenous people. It is generally good practice to use methods that have already been used successfully by other researchers, and that's what I did. I used measurements that had been used by other researchers that I knew were reliable. It would be a good idea to use one of the many approaches that have been used successfully by other researchers. This is good not only for the sake of feasibility, the approach is tried and true, but also because it provides greater continuity with previous research. I couldn't have compared my research to any other research if I had created my own resilience scale, if I had created my own cultural scale, if I had created my own trauma scale. I couldn't have compared it with anything else. All I could have said was, mine said this. Nobody else has ever done this research with this instrument before, so I don't know if it's really true or not. This makes it easier to compare your results with those of other researchers and to understand the implications of their research for yours and vice versa. The research literature is all the published research in a particular field. The research literature in psychology is enormous, including millions of scholarly articles and books dating to the beginning of the field. When did the field begin? Sometime in the middle of the 19th century. And it continues to grow. Research literature definitely does not include self-help and other pop psychology books, dictionary and encyclopedia entries, and websites. These are considered unreliable because they are not reviewed by other researchers and are often based on little more than common sense or personal experience. Wikipedia contains a lot of valuable information, but the fact that its authors are anonymous and its content continually changes makes it unsuitable as a basis of sound scientific research. The definition of research literature consists of two types of sources: articles in professional journals and scholarly books in psychology and related fields. Now, let me tell you this about Wikipedia. You can look at Wikipedia, you can get ideas from Wikipedia, and if you go to the bottom of the page, it will have references. And if you can use those references because those references are to actual scholarly articles. Now, some of Wikipedia, is questionable, and you couldn't cite Wikipedia because you don't know how accurate it is. You don't know if that piece of information came from there. However, if you look at the references at the bottom of the page, you can go to those references, and that's what you can find good references at the bottom of the page. What you might find out is the references that they're talking about don't have anything to do with the Wikipedia article. That's a possibility, and that's the reason that Wikipedia. I mean, we don't know who's writing the article either. They are all anonymous, so do not use Wikipedia as a source. But you might be able to find research articles at the bottom of the page that are good articles because they're scientific. Professional journals are periodicals that publish original research articles. There are thousands of professional journals that publish research in psychology and related fields. They are usually published monthly or quarterly in individual issues, each of which contains several articles. The issues are organized into volumes, which consist of multiple issues, all the issues for a particular calendar year. Although many journals continue to publish hard copy versions, it is more common now for researchers to find and read electronic versions on the internet. And this is a journal from the American Psychological Association, Cultural Diversity and Ethnic Minority Psychology. This has to do with indigenous peoples. It's a good one, and as you can see, and this is one of the reasons why we need good references. We need you to tell us where you got this information from. So if you had an article from the Cultural Diversity and Ethnic Minority Psychology journal, you would have to tell us that it came from volume 31, number 1, and then tell us what page number it is. Now, one of the new things that has been around for, I don't know, for about 15 years is DOI numbers. DOI numbers have to do with where you can find it on the internet. They're a digital organizational issue or something. That's what DOI stands for. Anyway, if you give us that DOI number, we can go directly to that article. Or we can actually, sometimes we can't find the whole article, we can find the abstract. Now, one of the problems, and this is a hint, one of the problems with AI is that AI makes up a lot of its material. Strangely enough, that's odd, and so they can't tell us where the information came from. AI can't because it doesn't come from any source. They just pulled it from the internet. This vague idea about something. Usually, the AI writing is very non-specific. And because of that, when they give their references, they give us bogus references, and that's how we can tell if AI was used. Because when they go to Cultural Diversity and Ethnic Minority Psychology, Volume 31, Number 1, and they give you page numbers, sometimes those page numbers are not one specific article, and the DOI number is bogus, and that's how we know. Giving you a hint and a warning. The other problem is, that, of course, with AI is that they get a compendium of thoughts on a specific topic, and a lot of those thoughts are just hearsay, and they're not accurate because they get all the negative, they get all the good stuff, they also get all the bad stuff, and they put it in the same article because they don't have the ability to tell whether an article is good or bad, and whether information is good or bad. So they put it all in there. And so there's going to be a percentage of what AI writes will be bogus information that isn't accurate at all. And that's why we don't want you to use ChatGPT. That's why we don't want you to use any AI. Because it's inaccurate. Sadly, it's inaccurate. Most articles in professional journals are one of two basic types: empirical research reports and review articles. Now, when I was teaching physiological psychology and what's the other one that I used article critiques? The other one was drug use and abuse, psychopharmacology. I had them write article critiques, and I wanted them to use research articles. Well, sometimes they would just find a really good article. This is a really good article about heroin, but it was just a review article. It wasn't a research article, and of course that I took off points for that because while this information is interesting, it's not research. It doesn't give me any new information. This is old information. Empirical research reports describe one or more new empirical studies conducted by the authors. They introduce a research question, explain why it is interesting, review previous research, describe their methods and results, and draw their conclusions. So what I would do if it was a meta-analysis, that was okay, but it needed to be an empirical research article. And I could tell that by looking at the number of subjects. If it had subjects, that meant that it was an empirical research article. No subjects, probably a review article. Review articles summarize previously published research on a topic and usually present new ways to organize or explain the results. Review article is devoted primarily to presenting a new theory or evaluating existing theories. Most professional journals in psychology undergo a process of peer review. Researchers who want to publish their work in the journal submit a manuscript to the editor, who is generally an established researcher too, who in turn sends it to 2 or 3 experts on the topic. Each reviewer reads the manuscript, writes a critical review, and sends the review back to the editor along with their recommendations. The editor then decides whether to accept the article for publication, asks the authors to make changes and submit it for further consideration, or reject it outright. In any case, the editor forwards the reviewer's written comments to the researchers so they can revise their manuscript accordingly. Peer review is important because it ensures that the work meets basic standards of the field before it can enter the research literature. So it needs to be peer reviewed. And this is the reason that Wikipedia isn't any good. The reason is because it's not peer reviewed. Scholarly books are books written by researchers and practitioners, mainly for use by other researchers and practitioners. They can be written by a single author or a small group of authors and give a coherent presentation of a topic, much like an extended review article. They can also have an editor or a small group of editors who recruit many authors to write separate chapters on different aspects of the same topic. Although these edited volumes can also give a coherent presentation of a topic, it is not unusual for each chapter to take a different perspective, or even for the authors of different chapters to openly disagree with each other. Scholarly books undergo a peer review process similar to that used by professional journals. This is a book by Philip Zimbardo. He's the one that did the prison experiment at Stanford University. It's a book called the Lucifer Effect. The Lucifer Effect is where somebody who's fine, who's okay, all of a sudden accepts an idea and runs with that idea, even though it makes them, it goes against common sense and it goes against they become evil, and that's known as the Lucifer Effect. And we see that in politics all the time. Is people that change their politics and all of a sudden they lose their morality. The primary method for searching the research literature is to use one or more electronic databases. The most important database for psychology is PsycInfo, which is produced by the APA and provided to libraries by vendors such as EBSCO or ProQuest. PsycInfo is so comprehensive, covering thousands of professional journals and scholarly books going back more than 100 years, that for most purposes its contents is synonymous with the research literature in psychology. And of course, Dene College does have PsycInfo, so you can use it anytime you need it. Another extremely useful tool is Google Scholar, which is an internet search engine that specializes in academic research for all disciplines. The benefits of Google Scholar is that it is freely available to everyone and it is extremely easy to use. Search results can be sorted by relevance or date and often include links to full text versions of articles and book chapters. If you create your own profile, you can also save the results of your searches for easy access later. Google Scholar is good. I have people write library papers. You're not going to do one in this class, but if you had been in another class of mine, this is probably it for me. I'm done teaching at Dene College as of this summer, I'm guessing. It is best to focus on recent research, keeping in mind that what counts as recent depends on the topic. For newer topics that are actively being studied, recent might mean published in the past year or two. For older topics that are receiving less attention right now, recent might mean within the past 10 years. You will get a feel for what counts as recent for your topic when you start your literature search. A good general rule, however, is to start with sources published in the past 5 years. The main exception to this rule would be classic articles that turn up in the reference list of nearly every other source. You should look for review articles on your topic because they will provide a useful overview of it, often discussing the important definitions, results, theories, trends, and controversies, giving you a good sense of where your own research fits into the literature. You should also look for empirical research reports addressing your question or similar questions, which can give you ideas about how to operationally define your variables and collect your data. It is good to use methods that others have already used successfully unless you have good reasons not to. And of course, I used three surveys that had been used before so that I could compare my results to others' results. You should look for sources that provide information that can help you argue for the interestingness of your research question. And now we get into research ethics. In 1998, a medical journal called The Lancet published an article of interest to many psychologists. The researchers claimed to have shown a statistical relationship between receiving combined measles, mumps, and rubella vaccine and the development of autism, suggesting furthermore that the vaccine might even cause autism. And this is the research right here. Wakefield was the guy's name. That was the guy's name. Follow-up studies by other researchers consistently failed to find a statistical relationship between the MMR vaccine and autism, and it is generally accepted now that there is no relationship between MMR and autism. But there are any number of people who have refused to vaccinate their children because they're afraid that they will become autistic if they get the MMR. Okay, so Wakefield has lost has lost everything. He was a medical researcher. He lost his job. Nobody will publish him now. He actually retracted the statement, the research. But there are still people out there that adhere to the idea that this is possibly true, despite the fact that science has said no, it's not. RFK Jr., who is I'm not exactly sure what his position is, but he believes that the MMR vaccine causes autism, as strange as that is. But as I said before, RFK Jr. is not a doctor. He's not a PhD. He's not a research scientist. He is a lawyer. So, and he's made millions of dollars off of the conspiracy. As weird as that is. So let's make him whatever he is. I'm not sure what his position is. Ethics is a branch of philosophy that is concerned with morality, what it means to behave morally, and how people can achieve that goal. It can also refer to a set of principles and practices that provide moral guidance in a particular field. There is an ethics of business, medicine, teaching, and of course scientific research. As the opening example illustrates, many kinds of ethical issues can arise in scientific research, especially when it involves human participants. Scientific research in psychology can be ethical only if its risks are outweighed by its benefits. Among the risks to research participants are that a treatment might fail to help or even be harmful. A procedure might result in physical or psychological harm, and their right to privacy might be violated. Among the potential benefits are receiving a helpful treatment, learning about psychology, experiencing the satisfaction of contributing to scientific knowledge, and receiving money or course credit for participating. Scientific research can have risks and be benefits to to the scientific community and to society too. Researchers must act responsibly and with integrity. This means carrying out their research in a thorough and competent manner, meeting their professional obligations, and being truthful. Acting with integrity is important because it promotes trust, which is an essential element of all effective human relationships. Participants must be able to trust that researchers are being honest with them, for example, about what the study involves, will keep their promises, for example, to maintain confidentiality, and will carry out their research in ways that maximize benefits and minimize risks. An important issue here is the use of deception. Some research questions are difficult or impossible to answer without deceiving research participants. Thus, acting with integrity can conflict with doing research that advances scientific knowledge and benefits society. Researchers must conduct their research in a just manner. They should treat their participants fairly by giving them adequate compensation for their participation and making sure that benefits and risks are distributed across all participants. Researchers must respect people's rights and dignity as human beings. One element of this is respecting their autonomy, their right to make their own choices and take their own actions free from coercion. Of fundamental importance here is the concept of informed consent. This means that researchers obtain and document people's agreement to participate in a study after having informed them of everything that might reasonably be expected to affect their decision. Another element of respecting people's rights and dignity is respecting their privacy, their right to decide what information about them is shared with others. This means that researchers must maintain confidentiality, which is essentially an agreement not to disclose participants' personal information without their consent or some appropriate legal authorization. It may already be clear that ethical conflict in psychological research is unavoidable. Because there is little, if any, psychological research that is completely risk-free, there will almost always be conflict between risks and benefits. Research that is beneficial to one group, for example, the scientific community, can be harmful to another, for example, the research participants, creating especially difficult trade-offs. Being completely truthful with research participants can make it difficult or impossible to conduct scientifically valid studies on important questions. One of the earliest ethics codes was the Nuremberg Code, a set of 10 principles written in 1947 in conjunction with the trials of Nazi physicians accused of shockingly cruel research on concentration camp prisoners during World War II. It provided a standard against which to compare the behavior of the men on trial, many of whom were eventually convicted and either imprisoned or sentenced to death. The Nuremberg Code was particularly clear about the importance of careful weighing risks against benefits and the need for informed consent. The Declaration of Helsinki was created by the World Medical Council in 1964. Among the standards that it added to the Nuremberg Code, that research with human participants should be based on written protocol, a detailed description of the research, that is reviewed by an independent committee. The Declaration of Helsinki has been revised several times, most recently in 2004. In the United States, concerns about questionable research practices led to the publication in 1978 of a set of federal guidelines called the Belmont Report. The Belmont Report explicitly recognized the principle of seeking justice, including the importance of conducting research in a way that distributes risks and benefits fairly across different groups at the societal level. The Belmont Report became the basis of a set of laws, the Federal Policy for Protection of Human Subjects, or the Common Rule, that applies to research conducted, supported, or regulated by the federal government. An extremely important part of these regulations is that universities, hospitals, and other institutions that receive support from the federal government must establish an Institutional Review Board, or IRB, a committee that is responsible for reviewing research protocols for potential ethical problems. An IRB must consist of at least 5 people with varying backgrounds, including members of different professions, scientists and non scientists, men and women, and at least one person not otherwise affiliated with the institution. The IRB helps to make sure that the risks of the proposed research are minimized. The benefits outweigh the risks, the research is carried out in a fair manner, and the informed consent procedure is adequate. The federal regulations also distinguish research that poses 3 levels of risk. Exempt research includes research on the effectiveness of normal educational activities, the use of standard psychological measures, and surveys of a non sensitive nature that are administered in a way that maintains confidentiality, and research using existing data from public sources. It is called exempt because the regulations do not apply to it. Minimal risk research exposes participants to risks that are no greater than those encountered by healthy people in daily life or during routine physical or psychological examinations. Minimal risk research can receive an expedited review by one member of the IRB or by a separate committee under the authority of the IRB that can only approve minimal risk research. Many departments of psychology have such separate committees. Finally, at risk research poses greater than minimal risk and must be reviewed by the IRB. Informed consent means obtaining the document and documenting people's agreement to participate in a study, having informed them of everything that might reasonably be expected to affect their decision. This includes details of the procedure, the risks and benefits of the research, the fact that they have the right to decline to participate or to withdraw from the study, the consequences of doing so, and any legal limits to confidentiality. Although the process of obtaining informed consent often involves having participants read and sign a consent form, it is important to understand that this is not all it is. Although having participants read and sign a consent form might be enough when they are competent adults, but the necessary ability and motivation, many participants do not actually read consent forms, or they read them but do not understand them. Even with competent adults, it is a good practice to tell the participants about the risks and benefits, demonstrate the procedure, ask them if they have questions, and remind them of their right to withdraw at any time, in addition to having them read and sign a consent form. Deception of participants in psychological research can take a variety of forms: misinforming participants about the purpose of a study, using confederates, using phony equipment like Milgram's shock generator, and presenting participants with a false feedback about their performance, telling them that they did poorly on a test when they actually did well. Deception also includes not informing participants of the full design or true purpose of the research, even if they are not actively misinformed. The APA Ethics Code allows deception when the benefits of the study outweigh the risks. Participants cannot reasonably be expected to be harmed, the research question cannot be answered without the use of deception, and participants are informed about the deception as soon as possible. This approach acknowledges that not all forms of deception are equally bad. It also acknowledges that some scientifically and socially important research questions can be difficult or impossible to answer without deceiving participants. Debriefing is the process of informing research participants as soon as possible of the purpose of the study, revealing any deception, and correcting any other misconceptions they might have as a result of participating. Debriefing also involves minimizing harm that might have occurred. For example, an experiment on the effects of being in a sad mood on memory might involve inducing a sad mood in participants by having them think sad thoughts, watch a sad video, or listen to sad music. Debriefing would be the time to return participants' moods to their usual levels by having them think happy thoughts, watch a happy video, or listen to happy music. Most contemporary research in psychology does not involve non-human animal subjects, though a significant minority of it does, especially in the study of learning and conditioning, behavioral neuroscience, and the development of drug and surgical therapies for psychological disorders. Non-human animals can be subjected to numerous procedures that are likely to cause them suffering. They can be confined, deprived of food and water, subjected to pain, operated on, and ultimately euthanized. Psychological research on non-human animals has resulted in many important benefits to humans, including the development of behavioral therapies for many disorders, more effective pain control methods, and antipsychotic drugs. Researchers must not fabricate data or plagiarize. Plagiarism means using others' words or ideas without proper acknowledgement. Proper acknowledgement generally means indicating direct quotations with quotation marks and providing a citation to the source of any quotation or idea used. Researchers should not publish the same data a second time as though it were new. They should share their data with other researchers, and as peer reviewers, they should keep the unpublished research they review confidential. The author's names on published research and the order in which those names appear should reflect the importance of each person's contribution to the research. It's very important that you get the order of the names correct. The one in front is the lead author, and that's important because the research will be known for the lead author. It would be considered unethical, for example, to include as an author someone who had made only minor contributions to the research, for example, analyzing some of the data, or for faculty members to make themselves the first author on research that was largely conducted by a student or another researcher. According to the APA Ethics Code, lack of awareness or misunderstanding of an ethical standard is not itself a defense to a charge of unethical conduct. This is why the very first thing that you must do as a new researcher is know and accept your ethical responsibilities. At a minimum, this means reading and understanding the relevant standards of the APA Ethics Code, distinguishing minimal risk from at-risk research, and knowing the specific policies and procedures of your institution, including how to prepare and submit a research protocol for institutional review board review. If you are conducting research as a course requirement, there may be specific course standards, policies, and procedures. If any standard, policy, or procedure is unclear, or you are unsure what to do about an ethical issue that arises, you must seek clarification. As you design your study, you must identify and minimize risks to participants. Start by listing all the risks, including risks of physical and psychological harm and violations of confidentiality. It is easy for researchers to see risks as less serious than participants do, or even to overlook them completely. Sorry, I needed a drink. Once you have identified the risks, you can often reduce or eliminate many of them. One way is to modify the research design. A second way to minimize risk is to use a pre-screening procedure to identify and exclude participants who are at high risk. You can do this in part through the informed consent process. A third way to minimize risk is to take active steps to maintain confidentiality. You should keep signed consent forms separately from any data that you collect and in such a way that no individual's name can be linked to their data. In addition, beyond people's sex and age, you should only collect personal information that you actually need to answer your research question. If people's sexual orientation or ethnicity is not clearly relevant to your research question, for example, then do not ask them about it. Be aware also that certain data collection procedures can lead to unintentional violations of confidentiality. When participants respond to an oral survey in a shopping mall or complete a questionnaire in a classroom setting, it is possible that their responses will be overheard or seen by others. If the responses are personal, it is better to administer the survey or questionnaire individually, in private, or to use other techniques to prevent the unintentional sharing of personal information. Once the risks of the research have been identified and minimized, you need to weigh them against the benefits. This requires identifying all the benefits. Remember to consider benefits to the research participants, to science, and to society. If you are a student researcher, remember that one of the benefits is the knowledge that you will gain about how to conduct scientific research in psychology. Knowledge you can then use to complete your studies and succeed in graduate school or in your career. If the research poses minimal risk, no more than in people's daily lives or routine physical or psychological examinations, then even a small benefit to participants' science or society is generally considered enough to justify it. If it poses more than minimal risk, then there should be more benefits. If the research has the potential to upset some participants, then it becomes more important that the study be well designed and answer a scientific interesting research question or have clear practical implications. It would be unethical to subject people to pain, fear, or embarrassment for no better reason than to satisfy one's personal curiosity. Once you have settled on a research design, you need to create your informed consent and debriefing procedures. Start by deciding whether informed consent is necessary according to APA standards. If informed consent is necessary, there are several things you should do. First, when you recruit participants, whether it is through word of mouth, posted advertisements, or a participant pool, provide them with as much information about the study as you can. This will allow those who might find the study objectionable to avoid it. Second, if you will be testing research participants in person, prepare a script or set of talking points to help you explain the study to your participants in simple everyday language. This should include a description of the procedure, the risks and benefits, and the right to withdraw at any time. If you will be testing them online, then of course this will not be possible. Third, create an informed consent form that covers all the points in the standards. If you are testing the participants in person, they can read and sign it. If you are testing them online, they can indicate whether they agree to be in the study by their response to a multiple choice item. Your university department or course instructor might have simple consent forms that you can adapt to your own study. And that is it. So I'll talk to you again possibly next week. And if not, hasta la vista.